Hello, everybody. Welcome back to the show, Science, Facts, and Fallacies podcast, episode 297. Almost there.
Almost to 300. That's incredible.
I know. I am impressed a little bit with us. I'm patting myself on the back right now. I don't know if you can hear that.
I can. And Kevin too. Kevin, pat on Kevin's back too.
Yes, we'll have to tag Kevin on number 300 because he carried a big part of the burden. And then you stepped into his shoes and have done masterfully. So yeah, anyways, we're moving along. Thank you all for joining us. My name's Cameron English. I'm your host. That is Dr. Liza Dunn, faithful co-host, toxicologist, physician, answerer of all the technical questions. And I'm very glad to have you handy today because this study we're going to be talking about has been all over the news. And it's complete bunk. It's complete hokum. I got to get my thesaurus up here to come up with some words, but I'll do that in a second. So let me just set this up, and then I'm going to turn this over to you because there's so much technical, nerdy experimentation going on here that most people, even the people that had very loud opinions about it, don't understand. You can just tell from what they've said about it. But here it goes. So at the beginning of October, so over 2 months ago now, the study was published in a relatively obscure journal called Chemistry, which is pretty infamous for publishing things that are of dubious quality. But in any case, they published this study that was conducted by people from Toxic Free Future, which is one of these anti-chemical activist groups. And they alleged that black plastic consumer products like spatulas, children's toys, these kinds of things, they contain hazardous flame retardants because these products are made from recycled electronics. So electronics, because they have a propensity to catch fire, are made with flame retardants. And some of these have been banned in certain countries. And like there is with almost any chemical, there is some research showing that if you feed a rodent, an inordinate amount of flame retardant, they might get a tumor. And so this is the foundation for this study. So this was published in Toxic Free Future, as most NGOs do very well, promoted this to the heavens. So every major news outlet covered this. CNN, The Atlantic, NBC News, the San Francisco Chronicle, the LA Times, anybody who's anybody in the media had a copycat story about this. And they all basically had the headline, something to the effect of, "It's time to throw away your black spatulas." Because there's hazardous flame retardants in them, and what about your children, and endocrine disruption, and you're going to grow a third arm in essence if you keep using your black plastic. Now the study itself, as we'll talk about in a minute, actually was unremarkable originally. There was nothing about it that was terribly insightful or helpful, frankly. But a little over a week ago now, there's a chemist at McGill University named Dr. Joe Schwartz. He heads up their Office for Science and Society. He does a great job of what we try to do, trying to explain these technical scientific issues to people in language they can understand. And what he pointed out is that the study authors, they exaggerated the amount of flame retardant that shows up in these plastic products by an order of magnitude. There is 10 times less flame retardant in these products. And what happened was, and Liza can explain what a reference dose is, but basically the EPA says, here's the limit for the amount of a chemical that you're allowed to be exposed to. And then it has to fall below that, right? So the reference dose itself is already artificially low. They find out how much of this chemical will harm you or cause any kind of biological effect. And then they go, you have to set it below that. Okay. So instead of being 80% of that reference dose, it was actually 10 times lower than that. I think that's how the math works out. So basically they multiplied wrong. They put a decimal in the wrong spot.
They did.
And what's fascinating about this is toxic-free future rushed out, and they to the scientist who corrected this, they said, "Thank you for pointing this out. However, it doesn't change anything about our study, its conclusions, its recommendations." So they did what you would expect an anti-chemical group to do, which is to say, data is what data is. We still have our conclusion. But more interesting, from my perspective as a science journalist, is that almost none of the reporters who covered this rushed out a correction. They didn't retract their stories. They didn't even put a note. There was no like, "Hey, FYI, turns out I didn't even read this paper, and the people that I got my information from made a terrible blunder. It was just a simple mistake, but with profound implications." None of the major outlets did that. Some of the smaller ones did. So like the Los Angeles or the San Francisco Chronicle, excuse me. That's a relatively big paper on the West Coast, but it's regional. It's not the New York Times. It's not the Washington Post. They came out and they said, here's what happened. We actually originally covered this, and so did all of these other papers. So to their credit, they corrected it. Wired, Ars Technica, a few other like specialty sort of science-focused publications explained what happened. And then Retraction Watch, which is a great resource, which monitors academic studies that are retracted, pointed out that there's a major index that lists peer-reviewed journals. They took Chemosphere out of one of the major indexes, because this is I don't know exactly what, but this is the fourth or fifth time this year that they've published an article that had to be retracted or it had to be corrected.
So they've had 8. I've got to look at exactly where I put it, but I think they've had 6 or 8 retractions in the past month, and then they've had 60 letters of concern sent to them since April. So this journal is not worth the paper it's printed on. It is spreading unnecessary fear and publishing garbage. And I think that this article may have been, and the reaction, the backlash to this article may have been the straw that broke the camel's back with that, because Clarivate delisted Chemosphere yesterday. And so it's really, really problematic when propaganda is being published that is not that there's no basis in science, and you scare people into. I tweeted this, and it's one of my viral tweets. It's had close to 400,000 views. It's been bookmarked 609 times, and it got lots and lots of responses. And it's because people are terrified of their black plastic because of this claim that went to the press. I think that what people don't understand is how heavily regulated this stuff is. You are not being slowly poisoned by all of the different things that you find in your surrounding. We have the safest and most reliable and abundant food supply, and the things that we make our food in and on are okay as well. Nobody is using plastic the way they used it in the experiment to extract these things, right? And tiny, tiny traces of chemicals are not harming you. So when you hear, the unfortunate thing is that the regulatory process is so boring to read about that nobody ever takes the time to read it. Just like many people don't take time to read the articles that they're being told are causing problems, right? So if you don't read the article itself, or if you don't have the background to understand the technical language in these articles, in the journal articles, it makes it very hard to interpret what they're saying. Everything from the statistics to the materials and methods that they use, that can be overwhelming for people. So people will take away just the conclusion in the abstract and then go, aha, I found this. So back to the trace detections. The trace detections, once again, they're regulated. There is an acute reference dose, which is similar to it would pretty much the same thing as the allowable daily intake. So when you're measuring residues of a chemical in food or in plastic or in whatever kind of thing that you are ingesting, they will have a threshold that is, I'm not even going to really say a safety factor, because you can't ever even reach that threshold. It's impossible physically to reach that threshold. So they make sure that the dose that you are getting is hundreds of thousands of times less than the allowable daily intake or the acute reference dose, right? The allowable daily intake is the non-toxic dose in animal studies with multiple safety factors built in. And so in order to reach the dose of quote unquote flame retardants that they were looking at, you would have to dissolve literally thousands of black spatulas and drink all of that in order to reach the allowable daily intake or the acute reference dose, once again, which is a non-toxic dose in animals. And so nobody's doing that in real life. And so these are not real world exposures. The dose makes the poison. That is a tenet of medical toxicology. And you are not reaching anywhere near that threshold dose that they're saying that you're coming close to reaching. So I hope that makes sense. I know it's like reading regulatory stuff is like watching paint dry, and that's what they're hoping for, because they'd rather have a good story.
Yeah, I wanted to punch myself in the face a handful of times as I was trying to read through this article, because it's incredibly technical, and it's why it pays to contact people like Liza, because they do this for a living. There's so much, like, I know not one single journalist that wrote up this paper understood what was going on in this. But let's just start here, because a lot of people focused on this mathematical error, which was embarrassing. I mean, the authors should have caught it themselves. Mm-hmm. But then the peer reviewers, if they were seriously looking, they should have said, hey, it's not 42,000. That's not the exposure. It's actually 420,000. Mm-hmm. So, I mean, that's massive. But one of your colleagues, Dr. Lyle Burgoon. Yeah. Burgoon. Okay.
Yep.
He's also a toxicologist, and he made a really good point in a thread where we were talking with another chemist, Simon Machling, who's also a great follow. But Lyle points out here that the original dose, assuming their math was correct in the study, that wouldn't have been problematic either. So let me read this. And he's talking about the reference dose here. So he says, being below the reference dose is great, and based on Toxic-Free Future's original incorrect value, everyone would be fine. TFF scientists misunderstood this and felt that 80% of the reference dose is problematic. It's not. And then he goes on and says, the reference dose isn't a bright line. You could be above it, probably very much above it in some cases, before you'll see any issues in even sensitive populations. Recall the exposure is a 70-year period when calculating this value. So that's interesting too. That's another detail that people don't realize. Like
you'd have to ingest this every day for 70 years to be to reach that.
Yeah. So in other words, you might actually die from natural causes or a car accident or something, like long before you're actually exposed to this at a level that could even potentially cause harm, right? So it's not like you're going to make pancakes one morning with a black spatula and then, fall.
All of a sudden be dead.
Right. You're not going to die. So I think that's a really important point, that if you just take as a baseline the study's original conclusion, here's a toxicologist saying, there's no there. And people overlook that.
People also made suggestions about how to replace their different what they cook with. They talk about brass and they talk about steel. Well, you can have cadmium in there. You can have all sorts of different things in those components too. You're not getting poisoned by them though, because they're alloys. So if you want to use stainless steel, fine. If you want to use brass, fine. But if you want to use plastic, that's fine too.
Yeah, and I don't like scratching my pans because pans are expensive. So I don't want to use metal. I use plastic because it's durable and it's cheap, and it preserves my pans. I don't want to scratch the bottom of my pans. For one thing, my wife yells at me when I do it, and that's frustrating in and of itself. But then I don't want to have to buy new cooking pans.
Yeah.
So this is, it's one of these things where it's like, it's at best an inconvenience that they're creating, and then at worst they're actually scaring people who have real problems. If you have young children, you have real problems. You have real things to worry about, and this is just a terrible distraction. And one thing I should add, I need to find the tweet where I put this out, but Toxic Free Future in their follow-up press release, they made reference to a lawsuit that's underway against the EPA by Earth Justice. So they didn't come out and explicitly say this, but what I suspect from reading it is they're not going to back away from their conclusion because there's this lawsuit ongoing. So if they were to come out and say, sorry, we forgot to carry a 1 and our results really aren't that scary anymore, the lawsuit looks even weaker. So I think that's one
right.
of the things. And in the paper itself, there's a section on policy implications where they talk about the need, of course, for more research, but then they talk about the need to regulate these chemicals more carefully, because one of the things they say is that these flame retardants aren't very well studied, and they're not regulated, or at least they're not regulated in recycled plastic products, right? So they're building a case for why you need to be scared of this and why governments need to do more. And it's not wrong to talk about those issues in the study, but it's clear from reading it that there is an agenda here. They didn't just happen upon black plastic and go, oh, gee whiz, let's look into this. There's more going on here.
That's exactly right.
Okay, I want to run this quote by you. This is from a chemist at, where university is that? This is actually in Yahoo Life. Of all the websites that publish really good coverage of this, it was Yahoo Life. It didn't occur to me that they would be good. Slate was really good on this originally, and so was Yahoo Life. But they quoted Jamie Allen. She's an associate professor of pharmacology and toxicology at Michigan State, and you alluded to this a little bit, but she pointed out, the methodology in this study was to take a plastic product, cut it into pieces, dissolve it in a solvent. I think it was toluene?
Toluene.
Okay, so they dissolved it and then they vaporized it so they could extract whatever, minuscule amounts of these chemicals were in the plastic. And nobody does that, right? I mean, you cook with a spatula, or your kid plays with a, whatever.
You'll get a lot sicker from drinking toluene.
Yeah.
Right.
So in other words, but the point, and again, Lyle talked about this a little bit too in the thread that we were discussing this, is that the methodology bears no resemblance to how you actually use these products. And it's interesting, like when the EPA looks at regulatory studies for a product before they authorize it, you actually have to test it, how it's going to be used, because that's how you're going to get reliable exposure data and how you can actually make judgments about public health. And so, in other words, the way that they're studying this is totally unrealistic. Maybe you can comment on that a little bit.
Yeah, well, once again, you see this over and over and over again in a variety of different studies. So, for example, sometimes there'll be studies that will on mice that people will do. Mice are rodents that people will do. They'll take a pesticide or a fully formulated pesticide. So that means it's got some surfactant and things like that. And they'll inject it into the abdomen of the creature. And they'll be like, oh, wow, look at all the damage it caused. Well, nobody is using pesticides that way. We aren't injecting fully formulated pesticides into anybody's gut. And so the methodology that is really important. And because if it reflects a real world exposure, so how are you exposed to the things, the everyday chemicals in your life, either through inhalation, through dermal contact, or through ingestion? Those are the usual routes that people are exposed to chemicals at all. And so those are the routes that should be tested. And then the way these chemicals are extracted make a difference. The way if they're applied to a petri dish on live cells, does that make a difference? You want to have as real world of an exposure as possible when you're doing your testing. And those tests are all run under what we call good laboratory practice. So they are validated forms of testing simulating real world conditions rather than giving people or giving animals huge high doses of something in a formulation that is not what you get on the market and through a route that's not what we do day to day. That does not give you an accurate reflection of how your exposure actually works. The other thing that they don't do well often when they're doing epidemiology studies in people. So those are toxicology standards for animals, but they also look at epidemiology study for people, and they like to make wild associations between what they call an exposure and an outcome. And some of these exposures aren't even really true exposures. They have not established whether or not people who have been in this situation have been truly exposed. So, for example, there's a study called Agricam that's come out of France, and they are following 180,000 people at taxpayer expense to see what kind of outcomes they have when they have pesticide exposures. And the way they define exposure is that if you are in agriculture in some kind of way, and you have a certain crop or a certain kind of livestock, and there is a chemical on the market that can be used as a pesticide in that crop or as a pesticide on that animal, you are automatically exposed to every single one of the pesticides that is on that market for that crop. Well, that's not the way it works. Farmers aren't going and buying every single organophosphate or every single pyrethroid or every single insecticide on the market to treat one pest infection. Likewise, they're not the same thing with herbicides and things like that. So the exposure definition isn't legit. It's like if you have an ear infection, it can be viral, it can be bacterial, it can be fungal, it can be inflammatory. If they're doing a study on your ear infection, you want to identify which one that is. You don't want to automatically say that the person's been exposed to every antiviral, antifungal, and antibacterial medicine on the market. And so the definition of exposure in these epidemiology studies is not clear. And the associations that they're making from these epidemiology studies are associations. Correlation is not causation. That's very difficult. They seize on these overexposures and weird routes of administration and weird ways of extracting things in animal studies. And then they overstate associations between what they deem as an exposure and outcome in epidemiology studies.
A few other things. If you read the paper itself, if you can make it through it without falling asleep, there is no evidence of harm, and the language is very careful. Mm-hmm. It's very qualified, because you have to in an academic journal. So if you actually read the paper, it's night and day from the press release that Toxic Free Future put out and the news stories. Yep. There's at no point does it say you should throw away your black plastic. At no point does it say if you use these products, you're going to have an endocrine disorder or you're going to develop cancer. It doesn't say that anywhere. And in fact, if you read the paper, they actually say 90% of the products we sampled did not contain flame retardants.
Exactly.
90%. Right? So if I was writing up this study, that would be in my headline.
Yep.
90% of black plastic products contain no flame retardants. Study finds.
That's right? Exactly right.
That's the kind of stuff people need to know.
And we talk about this all the time. So that there are so many problems. I'm going to go ahead and say it since it got delisted. This appears to be a predatory journal. That the article itself, because it's had so many retractions recently, the article itself is fraught with all sorts of problems, and it just made this huge splash in the press. And we've got to stop doing this. We got to get back to some sanity.
Yeah, let's talk about the media for a second, because I just love media criticism.
Mm-hmm.
I don't think this article itself is going to have an enormous impact. But one thing that you're seeing is the public's trust in media just absolutely plummeting. So in October, coincidentally the same month the study was published, Gallup reported the public's trust in the media is at an all-time low. It's just 31% of Americans say they have a great deal or a fair amount of confidence in the media to accurately report the news to them. So that means about 70% of people just disregard what the press says, because this happens over and over, right? They report a story, and there's been major stories that we don't need to get into that are much more political, where the press reported something and it was completely false. And then when it comes out that it was false, they either just ignore it, like many of them did in this case, or they just go, win some, lose some, our bad. Or they don't even say our bad. It's just sort of like, well, we did the best we could kind of thing.
Or they double down and say, well, we believe. Well, it's not about belief. It's about what objective scientific truth is. And I've been doing a deep dive on the literature out there on plastics and the different exposures that people have in plastics. And it is incredible how much money has been spent on this topic, how much overview and oversight EPA and FDA have on this particular topic. And it still is making even academics, it's making academics believe that there's something terribly, terribly wrong with all of these plastics everywhere. I agree that we shouldn't have floating islands of plastic in the Pacific, but I also think that we don't go demonize really useful plastics like PVC. PVC is so critical for everyday functioning, right? It's in all of our medical equipment. It's in blood bags, and for blood transfusions. It's really, really critical for water sanitation when you're talking about your pipes and things like that. It's much more durable, much more, believe it or not, lower greenhouse gas emissions, and much more climate friendly than many of the other things that it replaces. So it's funny. It's a good solution to a lot of the things that environmentalists complain about, but then they find something else to complain about. And while I really think that, this is our Garden of Eden, Earth is, and we got to take care of it. Whenever somebody comes up with a way to take care of it that comes from a company, there's so much shade thrown at it because people think that the company has got an ulterior motive, and it's very frustrating to watch people who have worked so hard to make things so much better get completely questioned by a media that won't listen to their side of the story.
Yeah, it's because they don't want to fix the problems. They want the problems to be insurmountable, and the only solution that they will accept is a lower standard of living for you and your family.
That's right.
That's what they're after, right? So if you can't save your food in plastic, then you have to buy locally grown, organic, magic fairy dust food,
And if you're way up north, you're not going to get oranges. You're not going to get You're not going to get all the stuff that you've become accustomed to.
Right. So your standard of living is going to be lower, but it's going to adhere to this rigid ideology of goofy earth worship that they are driven by. Now, they don't say that in their press releases, but if you read some of the work that they've put out over the decades, especially earlier on before they were less savvy from a public relations perspective, they would just come out and say, we need fewer people and we need less of this, and you need to use less energy and you need to eat less food. And, that is what they're after. They're after a total reorganization of society. And
they plainly state it. And it isn't until the advent of social media that the things that people were able to have access to that information that was out there. You'd have to know where to go to look for it. You'd have to, and when you've got social media, there's some good things and some bad things. But one of the good things is I think that you actually get to learn and read them in their own words so you can see what they're saying for yourself. You may not be an expert at things, but I think it's really important to utilize this new tool in a way that could be really beneficial for society. And that's why these science communication things are so important. I think that there are not enough people who are good at scientific communication who can go and talk to journalists and go and talk to different regulators, legislators, and things like that to explain why things like this are terribly flawed and you don't have to be scared.
Expertise is enormously important. That's why I did the show with Kevin before, and that's why I do the show with you. And that's why everything I write is reviewed by somebody with the appropriate credentials.
Yeah.
Just today I was working on a story and I had 3 people,
look at it
with medical backgrounds and chemistry backgrounds. And I said, make sure my numbers are right.
Yep.
I want to be right about this,
Yes. Yeah.
That's vitally important. But the point is, you go to experts so you can learn things and so you can apply the information that you're hearing from them to the circumstances that you're in. And that's often missed, you should like if Liza was to say this chemical doesn't pose a risk to you, I would just go, okay, because you have shown over and over that you're giving me accurate information. But the thing that's often the message that's communicated by the press especially is that this expert says this. It might as well be written on a stone tablet. It might as well have come down from heaven with angels singing and a bright light, and here comes the, it's like, that's what they want. They want you to say, I talked to this person, they have lots of letters after their name. They work at a group called, Moms Concerned About Chemicals, and so they're pure. And that's where the conversation is supposed to end. And I think what this story in particular illustrates is it can't end there because they're bluffing a lot of the time.
That's right. And it's also important to understand that scientists can be wrong occasionally. And even the experts can get stuff wrong. And the only way to build credibility is if you admit that you're wrong. And that's what they're not doing. There are so many papers in so many journals that are absolutely fatally flawed, and they have never been retracted, and there's never been an apology for them. I mean, the fact that the Lancet has had that glyphosate is an organophosphate live since 2015 for almost 10 years now means that doctors who don't know better read that, and if they have somebody with that kind of overdose, they're treating that patient with the wrong protocol, and that protocol could hurt the patient. It's never been retracted. And to me, that's fundamentally a really important part of science. Scientists are smart and experts are smart, but their hubris gets in their way. And we need to have a very close look, because I think that there's a lot of, that's why people are buying the anti-vaccine movement, and that's why they're buying that all of these microplastics and these flame retardants and all these chemicals are so bad, because they're hearing a narrative that is not based in science but seems science-y. And there are the people writing this stuff often have ulterior motives.
I made this point in one of our recent spaces. A lot of that rhetoric is coming from the academy. Mm-hmm. There are major journals that everyone looks at and goes, that's a legit science journal, publishing nonsense about microplastics. Mm-hmm. And they're not necessarily bad studies, but they are, like they cut open a cadaver and they go, oh, this person had microplastics in their liver, right? And then that gets translated into a news headline, dead body has microplastics. And then it becomes this narrative about how these plastics or how these pesticides or whatever, it's in the very air you breathe, That's the problem. It's not just Kennedy. It's not just all of his hooligan friends. It comes from people who are very smart, who know how to do experiments like the one we're talking about. That's got to stop. That's got to stop.
The claims are completely overblown for what they're finding.
Let's wrap it up here. But one thing I want to say before we go, let's talk about the regulation of these. Because one of the, I think, worst lies that these activist groups tell is that these products are virtually unregulated. There's just like some megacorp somewhere in the southern part of the U.S. They just set up a giant polluting factory and then they dump chemicals into the drinking water and there's nothing that you can do, right? It's total. It's just ridiculous. Like, I'm almost offended at how dishonest that is. And here's a good example. The Consumer Product Safety Commission, it's a federal regulatory agency. They have enforcement authority. There's 15 different laws that grant them authority to regulate different consumer products, like the toys your kids use, all kinds of stuff. They can pull things off the market. They can fine. I'm pretty sure they can fine companies if they're not in compliance with the law. You know, and they work with different industries and different trade groups, and they say, here's what. And it's not, strictly speaking, this part is not mandatory, but it's sort of like if the mafia in your neighborhood is like, you know, like you really need some protection, buddy, because
yes,
you know, your store could get firebombed, and we don't want that. It's that kind of thing, right? It's voluntary, but if the federal government gives you advice, you know, you need to follow.
You take it, yeah.
So there's that, but then on like with the EPA has a lot of authority over like the chemicals that are used to manufacture products.
Yes.
So if they were discovered something, they don't want to be blamed for, you know, children eating flame retardants. So if there was a problem, you can bet your ass they would be involved.
That's exactly right.
So yeah, and then the FDA has like a lot of the concern in the study was about food contact materials. The FDA has total authority over that,
and they totally regulate it. They totally regulate it. And the people are like, oh, you know, they don't regulate it well enough. We know. They do their own studies. They look at a whole bunch of body of regulatory studies that companies do. People go, oh, you know, companies producing studies, that's biased. Well, don't you want the companies to do the studies to make sure that the products they're putting on the market are safe for you to use? The taxpayer shouldn't have to pay for that, right? The companies should have to pay for that. The companies have very strict criteria under which they do these studies. And so, like I said, GLP studies. FDA, for example, everybody keeps on talking about BPA, bisphenol A, and talking about how it causes all sorts of health effects and things like that. FDA has looked at this backwards and forwards and inside out. I'll even do a quote. Let me see if I can quote. Let me pull it up really quick. The dog is snoring, so I hope it's not. I hope it's not making noise in there. Yes, he's snoring. It's okay. I can't find it.
While you look for that, I've got a couple here. So, with BPA.
Oh, here you go.
Go ahead if you're ready. I've got a couple of these loaded up.
Yeah. Quote, FDA has performed extensive research and reviewed hundreds of studies about BPA's safety. We reassure consumers that current approved uses of BPA in food containers and packaging are safe. The FDA continues to monitor the scientific literature for new research that helps enhance our understanding of BPA, and will consider new data as it continues to ensure the safe use of BPA in food packaging.
They published. Go ahead, please.
They've been asked to review this over and over and over and over and over again, and they have reviewed it over and over and over and over again. And it comes to a point where, you know, we're in the middle of this potential government shutdown right now, and people are discovering that their taxpayer dollars are going to a whole lot of stuff that they don't need to go to. If something has been on the market and has been demonstrated to be safe by multiple studies over multiple years by regulators and independent researchers, then the taxpayer shouldn't have to pay over and over and over again to reconfirm what people don't want to hear.
So yeah, moral of the story, toxic-free future is full of fiddlesticks, blarney, horse feathers, senselessness, taradiddle, fiddle-faddle, hoodoo, hooey, bunkum. It's nonsense, everybody. This study is junk. Everything they're claiming. It's just wrong. And as you pointed out here, most of these studies aren't retracted because the errors like this, like the headline-grabbing errors, are not caught. They're
That's
bad
right.
studies, and they don't prove anything more than a statistically insignificant association.
That's right.
The science journals are full of that. I've made a career out of just ripping this kind of stuff apart. It's awful. It's awful. So, yeah.
But when they're retracting whole journals, you may want to think twice. If this article's in that journal, maybe I should look somewhere else.
And it's funny. I have to be very careful when I'm doing research for a story because a bad journal looks a lot like a good journal. And sometimes you have a publisher that owns a good journal and a really sucky journal. You have to be very, very careful. So just a little bit of skepticism. And have a Merry Christmas, everyone. Enjoy time with your family. Eat good food. Serve it with black plastic. Nothing's going to happen to you.
Nothing's going to happen.
You might be kind of bloated and lethargic after all the mashed
That's
potatoes.
Right. Or the turkey tryptophan.
Yeah. Yeah. All the carbs, all the tryptophan, all the alcohol, no doubt. I'm sure lots of people are going to be enjoying spiked eggnog. Anyways.
There you go.
We're done. We're about to go jump on our space. So by the time you see this, it'll be over, but we hope you join us. And if you missed this one, come to the next one. Every Friday, the new time is, help me out here.
We did 3 p.m. Central Standard Time. So we're going to see what the turnout's like for this time.
Yes. Okay. So for now, it's 3 p.m. It's every Friday, though. It's going to be sometime on Friday afternoons. Follow us on X. It's at Dr. Liza MD, at CamJ English. And we'd love to talk to you. We'll tell you when the spaces actually are. Thank you so much, and we'll see you next time.
Bye-bye.